Let's say that you take two tests. On test 1, there are 5 people in your class on each test. On test 1, these are the scores, and on test 2, these are the scores. Now if you average both of these, if I've done the arithmetic correctly, which is always something you need to check me on because I do it all mentally and do make mistakes, but I believe that if you average these numbers, find the mean, and find the mean of these numbers, in both cases you get 85. So what's the difference between the distributions? Well, you know that the standard deviation is going to be larger for this set of data than this, because this data is more spread out than this data. And if you calculate the standard deviation using the methods of the previous section, you're going to find that it's 3.4 for this distribution and 9.6 for this distribution. So the question is, well, let's say you make 90 on the test. Where do you stand with respect to the rest of the class? Well, one possible answer is obvious. You got the highest grade here, and you got the second highest grade here. A little more descriptive information might be, how far were you from the mean? Well, here you differed from the mean by 5, and here you differed from the mean by 5, because the mean is 85. Now, there's your 90. Okay, so the difference between your grade and the mean in both cases is 5. You're 5 points above the mean. So did you do better on the first test or the second test? Well, the first indication, you had the highest grade in the first test, only the second highest on the second test, tells you something. It tells you probably actually did better relative to the rest of the class on the first test than you did on the second. The other question, though, is how can we quantify how much better you did? So we're going to ask the following question. Okay, you make a 90. How many standard deviations are you from the mean? Okay, well, in the first one, standard deviation is 3.4, and you're 5 away from the mean. You were 5 points better than the mean when the standard deviation is 3.4, so you're more than one standard deviation from the mean here. Whereas, in this case, being 5 points again from the mean, you're less than a standard deviation from the mean. So in that sense, you're closer to the mean in this case than you are in this case. Even though your raw score is 5 points away from the mean in both cases, since the standard deviation here is greater than the standard deviation here, you are closer to the mean here than you were here, and you actually did better on this test. Now, how many standard deviations are you from the mean? Well, if you're 5 units from the mean and the standard deviation is 3.4, as we say, you're more than 1 and less than 2 standard deviations. 5 is more than 3.4 but less than 2 standard deviations, which would be 6.8. So somewhere between 1 and 2 standard deviations. How do you think we're going to get the exact number of standard deviations from the mean? How many standard deviations are you from the mean in this case? Well, okay, you're plus 5 from the mean, and that means if the standard deviation is 3.4, then you're 5 over 3.4 standard deviations from the mean. You're 5 3.4ths in a way of speaking. Whereas in this case, where the standard deviation is 9.6, you would be 5 9.6ths. 5 over 9.6 standard deviations from the mean. So that simple ratio tells you how far you are from the mean. And of course, the 5 over 3.4 is more than the 5 over the 9.6. On the first test, then, we're going to say that your z-score is 5 over 3.4, or 1.5. Z is the number of standard deviations from the mean. Z is the number of standard deviations from the mean. In the second test, Z would be 5 over 9.6, which is 5.2. And these deviations are positive, so we're at plus 5.2 here and plus 1.5 here. What did we do? What we did is just common sense, but we can formulate it a little bit. Z equals your deviation from the mean divided by the standard deviation. And again, Z is the number of standard deviations from the mean. Now your book is going to give you a more detailed formula. You don't really need that formula if you understand what this means, but it doesn't hurt to have the formula, as long as you don't just think formula, plug in number, plug in number, plug in number. You want to think formula means number of deviations from the mean over standard deviation, so you keep refreshing yourself on the meaning of this thing, because you're going to forget that formula. If you visualize what you're doing here, you're not going to forget the meaning of the Z-score.